欢迎各位与会的朋友们回到我们今天下午场的场次。接下来下午场我们要进入本次国际研讨会的主题5，来跟大家谈一谈数位科技的应用、智慧家禽的转型。接下来下午的场次，我们分别邀请来自台湾还有英国的2位专家来跟我们分享在智慧化家禽养殖业方面的经验。那么我们待会会先听到有来自台湾的专家分享之后，我们会听到来自英国的专家分享。那么最后则是我们的综合座谈语谈的时间。今天下午的第一个专题演讲，非常高兴能够邀请到立瑞畜产有限公司的王雅慧总经理来跟我们谈家禽养殖智慧化与溯源管理的应用。请大家一起掌声来欢迎王总经理。
各位老师、各位与会来宾，今天很高兴能够来到这么好的一个场地，来跟大家一起分享我们这几年所做的一些智慧化的一些系统。那现在我先寻常例先介绍一下我们公司。我们立瑞它成立在2004年，我们从育种、饲养、电改、加工、包装、行销的有色基一条龙的公司。然后我们在2012年的时候新建我们的电宰场，取得我们的屠宰场登记证。在2014年，我们全场通过 CAS、HACCP、ISO 22000的认证，然后建立我们的产销履历系统。在2015年的时候，取得哈拉清真认证，完成全国第一个土鸡产销履历的集团验证。在2017年的时候，我们第一间实体店面在台中成立，然后2018年开始开放我们的特色汤品厂跟我们的零售通路。在2019年的时候，云岭鲜鸡翅与 B 鸡精荣获我们的业界第一家荣获 AA 无添加3颗星认证，还有我们的云林良品礼赞奖跟农村好物。然后再介绍一下我们这几年在牧场端所做的一些在智慧禽舍里面所做的一些努力。那在2015年的时候，我们新建了我们土鸡第一座全负压鸡舍的云林畜牧场，它是采用美国的艾伦科技跟我们国内的扬雅科技所做的一套系统。那2016年的时候，我们首先引进了土鸡负压水帘式鸡舍，这个利和畜牧场它使用的是 SCOPE 系统的。然后2016年的时候，我们跟农委会配合，有做了一个农业生产力4.0的先导计划，然后做一个 ERP 的系统整合。在2017年的时候，我们用老旧鸡舍下去盖国产的智慧化，控制我们有色鸡的鸡舍。这个在我们彰化的大湾新畜牧场。在2017年、2018年的时候，我们参与智慧农业4.0家禽产业计划，合作开发我们土鸡饲养智能化管理系统。这个场域在我们云林县的新河畜牧场。2019、2020年，土种鸡智慧生产管理体系跟消费溯源平台的建立。以上的这一些呢，是我们这几年在我们的智慧化禽舍升级上面所做的一些努力。我们公司的经营理念是，我们公司主要经营的业务项目是土鸡。那各位相信说，大家对鸡都有非常多的一个了解，但是对于土鸡，可能大家了解的不是那么多。主要大家了解的有可能是白肉鸡。那白肉鸡是一个国际化的一个鸡种，但是土鸡不一样，土鸡是我们台湾特有的特色鸡种。那这个特色鸡种，我们希望说，我们在台湾本地，我们希望能够我们把来自于我们的产地严选，用科学化的管理来做我们的育种，然后在我们的饲养的时候，我们用竹林的饲养，让我们的土鸡肉质 Q 弹，跟它的风味可以让消费者可以知道。然后在我们的电宰方面，我们希望说，透过第三方兽医师驻场，能够让我们的一个屠宰流程是安全、是卫生的。然后在我们专业加工，我们也透过一些透过国家的认证来取得我们安全品质上的把关。 我们在每一批次的鸡只进来之前，我们一定先做我们的药材检验，确保每一只鸡到消费者的口中的时候，它的安全是没有疑虑的。然后希望我们开发了多种的商品，希望说能够让这些的吃到嘴巴里面去的土鸡每一个产品都能够让消费者的喜爱。这是我们公司的一个整个的经营模式。我们这么多年来，应该说也要很感谢农委会的支持。然后农委会对于我们土鸡这个产业，其实它也用了很多心在跟我们做辅导。那因为其实大家应该都知道，白肉鸡的一些设备，因为它的量能的一些关系，所以它的，简单的说好了，白肉鸡的饲养场，整个台湾大概有1000多场的饲养场。但是它的周产量大概有450万只，在台湾国内的白肉鸡的产量，但是土鸡它的产量大概只有，一周的产量大概在180万左右，但是白肉鸡的饲养场只有1000多场，土鸡的饲养场有2000多场，所以代表说我们土鸡其实是规模比较小，然后但是它的人比较多。所以说，在这些的情况下，我们要去整合土鸡这个市场，然后要让土鸡把这个土鸡的好的品质给保存下来，我们需要有一些工作要做。所以我们公司就去做了这种模式。我们希望说，我们每一只鸡进到我们里面的时候，它都是健康的。我们也希望维持它的鲜度，然后我们也希望说能够能够用最能够接近消费者的方式。然后让我们的土鸡能够让更多的消费者去做接触，所以每一个环节我们都去做把关。我们希望说用专业的饲养、先进的店长，然后更多元的创意美味，来让我们土鸡更接近我们的消费者。不然的话，以土鸡每周产量是450万，然后进口的白肉鸡也大概是450万至500万。在这种情况下，土鸡很快会被淹没不见，然后消费者很容易有可能就忘了我们土鸡的鲜甜美味，然后忘了我们在台湾还有台湾土鸡这一样的产品。这个是我们在整个为了土鸡所做的一连串的产业里面所创立出来的一些公司跟一些品牌。饲养在农业方面，我们在育种方面，我们在2015年的时候，瑞兴农业最主要做的就是台湾土鸡的品种进行育良改种的育种公司。那我们现在的所在地是在中兴大学。那我们瑞兴的名字是怎么来的？瑞就是我们利瑞的瑞，兴就是中兴大学的兴，所以这是我们的育种公司。然后我们还有另外一个，就是我们有一家蛋鸡场，它是云林县首家通过鸡蛋产销履历跟动物福利双认证的蛋鸡场，它推广的是动物福利鸡蛋。然后我们的力高生鸡，为了土鸡，我们去成立了一家加工厂。这个加工厂它的主要业务就是为土鸡做土鸡的产品的更多的研发，希望说把好的土鸡肉的加工品可以让消费者更容易接触得到。然后我们从云里鲜鸡，透过云里鲜鸡这个品牌来推广给消费者做认识。这个是我们的智慧化养殖。刚刚我所介绍到有很多的这些年所做的，其实就是在这一些的系统里面，我们可以看得到。我们在这边，这个就是我们可以用手机随时监督我们鸡只的生长环境，然后我们用各式的感测器，然后去收集我们的牧场环境资讯，透过环境资讯，我们来做一些智慧化的应变。这个现在介绍的是我们刚刚介绍的那些所做的那一些里面，它里面的一些系统。我们里面有称重系统，这个是大湾星鸡舍，我们里面有称重系统，还有二氧化碳的感测器，还有热线式的风速计。 然后室外温度感测器、负压感测器、室内温度感测器、二氧化碳、一氧化碳，还有氨气的感测器，跟我们的电脑管控面板，还有我们的操作系统。这个是另外一套的系统。然后这一套系统里面，我们可以看得到的，这也是一样是一个电脑管控的系统。这一套，因为这个是我们国内自行开发的，然后这个是来自于美国的，爱罗科技的导入的。然后我们之所以后来会倾向后来希望说用国产智慧化的一个感测设备，其中有一个原因是因为国外的导入的负压设备里面的感测器跟里面的电脑设定系统，其实都是针对白肉鸡所下去做开发，下去里面的生产曲线也好，里面的环境参数的设定也好，其实都是依据白肉鸡去做开发。那因为台湾土鸡是台湾在地品种，那我们跟国外的一些环境可能不太一样。在国外的环境参数，所有的一些设备你拿过来直接套入国内的系统，对于国内的土鸡来讲，有可能其实并不是那么适合的，所以我们才会去开发说国内的自己的一个负压的电脑管控系统。然后我们在里面为了达到说我们更好的一个监视的，可以让我们更清楚去了解到我们牧场环境的一些参数，所以一些参数跟一些现场实况，所以我们里面都会有监控系统跟一些简报器系统。我们可以很清楚的知道说我们的每一栋鸡舍里面目前所处在的是什么样的一个环境。这个是它的外观，这个是那时候入主的时候我们的小鸡周岭，然后这个是水源设备。一样是云林里面的，云林畜牧场里面的一些主机啊、温度计、温湿度计，跟我们的操作面板，跟我们的电脑系统。然后里面有新和畜牧场，这个就是我们国内自行，也是我们国内自行开发的，里面的一些sensor称重、饲料称重，还有鸡只称重。然后我们的电脑管控面板。这个是我们国内自行开发这一套系统，目前我们使用起来，它是一种智慧化的 AI， 而且它可以自动控制。那自动控制，比如说好，我们现在外面的，刚刚的问题好像有人去问到那个温度跟湿度，还有台湾，因为台湾是高温多湿的天气，以室内的禽舍，我们怎么去控制它的湿度？我们这些年来在于密闭式禽舍里面的饲养经验来讲，其实里面的湿度基本上是可以控制的，但是在一个季节的时候很难去控制到，就是夏天我们很难去控制，为什么？因为我们在冬天的时候，我们里面的湿度其实可以透过我们的抽风系统去把我们里面的湿度给拉出去。可是因为在夏天的时候温度太高，当我们温度太高，因为我们是自动控制嘛，我们的最高温假设我们设定在28度、29度，但是夏天的高温经常它会飙到35度以上，甚至于37度、38度，好，一定是在那么高温。那你的环境在那么高温的情况下，它拉那个抽风速度没有办法将你里面的热度完全带出去的时候，我们需要启动水帘设备。当你水帘设备启动之后，温度还在降不下来的时候，我们又会自动启动室内喷雾系统。室内喷雾系统我们还会再依时间的区段，就比如说我现在拉到我的室内温度现在要设定到28度嘛，然后它拉下来可能只能拉到32度，32度的时候透过水帘只拉到32度，我这个时候就一定要启动喷雾系统。喷雾系统有可能我现在是100秒喷了20秒或30秒的喷雾，但是如果还没有办法降温的时候，我的100秒可能会降成60秒喷30秒，就会这样子 这样子不断的去施以喷雾，目的就只有一个，就是我要把里面的温度给拉下来。可是喷雾用太多的时候，就会造成里面的湿度过大。那里面湿度过大，这个时候就有可能造成我们的室内湿度太高。这个时候也很容易造成我们在饲养场的一些疾病困扰，还有就是我们鸡只的反应。如果有学畜牧的，应该就知道会有一些臭脚的情况，就是垫料潮湿，阿莫尼亚的味道就会产生，对我们的鸡只会产生不良的反应。那整个以密闭式禽舍的这个整个饲养状况来讲，大概就只有夏天这种情形会最难控制。那但是通常这种情形，我们会透过一些人力的方式，比如说我们可能会在我们的喷雾系统里面，或者我们的饮水系统里面，我们会加冰块，我们让它的降温能够来到最快，然后尽快把温度给降下来。这样子的话，我们的里面室内温度的湿度也比较不会那么高。这个一样是电脑，这个是我们整个利和畜牧场，这采用的是一个 Scope 的设备，里面这里也是一样，都是这里它采用的土鸡舍跟一般的白肉鸡舍不一样，在于它的采光，我们有整面的采光，因为我们需要阳光紫外线，让我们的鸡冠能够看起来是红彤彤的，然后很漂亮。然后这里有一个侧窗，这个侧窗是我们在冬季的时候，因为有时候冬季外面的气温非常的冷，那我们就不能开启风扇，我们就用侧向的侧窗来做通风。这是我们的数据资料跟我们的一些监视系统，然后里面可以收集很多数据。那这些数据的话，可以提供我们做判断。然后也可以让电脑去做一个它的数值设定的运算。这个是利和的一个操作系统。这个是我们在去年度所刚新建的台湾，可能是土种鸡场，没有人用密闭负压的方式下去做饲养。这个是我们第一套在嘉义的大里面，它有温度感测、湿度感测、室外温度负压感测、风速感测器跟电脑管控系统。这一套设备用的是 BD 的系统，里面的电料啦、饲料磅秤这些的所有，不管刚刚讲的这么多的数据收集，其实目的都只有一个，我们希望说给我们的鸡只最好的一个环境。我们希望说，我们能够在充分的节省人力的情况下，能够达到一个最好的管理。我们的溯源系统，就是希望说用 RWD 响应式设计对应跨平台的数位资讯，呈现需求、消费者需求怎么样去回馈来，然后消费者的需求，消费者要从哪里去追溯到我们饲养场的资料。这个是我们今年度目前还在计划中所在做的一个计划性的内容。这是我们溯源平台的一个设计的架构图。透过我们溯源平台，我们可以连接到我们的牧场端，让我们的消费者知道说，我们这只鸡到底是怎么样养大的。养大之后，它现在嘴巴里面吃的这一只鸡，它有怎么样的一个生长历程、生长故事？那它在哪一个县市所饲养生产？然后我们也整合我们的图画，资讯整合跟我们的图像化设计，这些的动作其实就是要让消费者知道台湾土鸡的存在。以上这些也全部都是我们的资讯整合，都是在今年计划内的，让消费者知道我们从育种开始，台湾土鸡从育种开始，然后在它的饲养，在它的屠宰，在它的加工，每一个环节它都是健康的、安全的。 我们的资讯影音视觉化，希望说让消费者，当然刚刚我们有看到很多的讯息，有很多的资讯，有很多的数据，这些消费者是看不懂的，所以这些东西我们用了图像化的设计，然后来让我们的消费者知道什么叫土鸡，我们怎么养土鸡的。所以我们在今年度我们也拍了5支影片，这个就是我们的云林5月天，这上面全部都是我们中兴大学的学生，很帅哦。我们云林5月天，然后我们也用这一些的资讯化设计，还有用这一些的电脑 sensor， 我们要做的就是跟符合上面，早上有一些讲者他有讲到的一些问题，就是农业缺工。我们希望的也是吸引年轻人可以回到农业这一块的领域，来加入我们农业。我们告诉我们的消费者，我们怎么去养鸡，我们用什么样的设备去养鸡，然后这一只鸡，它从育种、饲养、加工，这一只鸡它的旅途是怎么样？我们如何让它从产地到餐桌，让它清楚，用图像化的方式，然后用比较，我们的消费者可以接受的一个表达方式，让他去亲近我们的台湾土鸡，结合消费者的需求，让消费者最后能够到市场上去，让消费者去知道什么是台湾土鸡的台湾味。我们的 ERP 生产资讯系统的一个整个串联。主要这些 ERP 系统最重要的一个部分，其实在便于我们内部管理。我们内部管理，我们需要透过我们的管理，就是我们掌握到最新、最及时的资讯，我们来做我们的一个判断跟我们的一个应变，也让现场的管理者可以现场的管理者他能够知道说他的机制现在有什么样的状况，然后也把讯息迅速的回报到公司系统、公司的管理系统里面。那这些是我目前所整合出来的一些资讯。我们现在尝试着建立属于我们台湾土鸡的一个生长曲线。台湾土鸡其实，如果大家对台湾土鸡有熟悉，就知道台湾土鸡目前其实它的鸡种非常的复杂，举凡各位所可以想象得到的，红羽土鸡、黄金土鸡、黑羽土鸡、古早鸡、斗鸡、珍珠鸡，在我们台湾的归属里面，我们的分法里面，它全部都是台湾土鸡的一环，包括乌骨鸡也是台湾土鸡的一环。那这么多的鸡种，你怎么去把它设定一个生产曲线？我们现在就是尝试着要把这些鸡种去透过数据的收集，把我们台湾土鸡特有的生产曲线给找出来。所以我们需要收集很大量的资讯。当然有很多的资讯，有可能就像早上的讲者也有提到，有一些可能是无用资讯，可是我们不知道什么是有用的，我们只能收集大部分所有我们可以收集得到的资讯，然后慢慢的去做判读。这个是我们自己设定的一个 ERP 系统。我们的系统就是让我们很清楚，我们今天这个厂它所投入了哪些成本，使用了什么样的鸡种，然后我们的整个饲养过程里面做了哪一些动作，我们得到了什么样的收获，我们的市场通路从哪里过去。然后这个是我们的一个整个的这一场3个月之后结束之后，我得到了哪些东西？它里面的资讯是哪些是我所可以去掌握，哪些我可以再改进的，我们都可以透过一个整合表下去了解到这一些的资讯。很简单的，我现在做一个结尾，就是我们希望说，台湾土鸡现在其实台湾土鸡很多人饲养，刚刚有说到 我们台湾土鸡的饲养户其实有2、3千户，在这2、3千户的台湾土鸡的饲养户中，虽然有这么多户，可是我们台湾土鸡其实是面临到危机的。我们的危机就是白肉鸡的生长速率实在是太快，它35天可以上市场贩售。可是我们的台湾土鸡，我们需要我们的饲养周期到12周、13周，就是90天左右。90天左右的饲养周期跟白肉鸡的饲养周期几乎是白肉鸡的3倍。那我们变成说，在面对消费者的选择的时候，我们的 GP 值在消费者眼中是比较低的，而且西化的饮食习惯影响。所以说，我们台湾土鸡目前它的消费力跟它的产量，其实是有呈现一个缓慢下跌的一个曲线。所以说，我们希望说，我们能够，我们一直从事在很专业在台湾土鸡这一块。那我们希望说，我们在做的很多的动作，我们都是希望说，我们能够为台湾土鸡尽一份心力。我们的智慧化的禽兽，我们结合多种感测器、多种智慧化的管理设备，我们改善我们土鸡饲养场的环境设备跟饲养的管理模式，希望我们能够运用智慧环控系统跟自动调整环境参数的功能，找出适合我们台湾土鸡的生长环境跟改善生长环境的参数。我们要用这个来提升我们土鸡的生产性能。也希望期许我们台湾土鸡能够透过完整的产销履历，还有透过我们智慧化设备优化、大数据的收集，跟我们的溯源系统平台的建立、影像传播跟消费者的需求，能够将我们的台湾土鸡的市场扩大，也希望能够形成一个优良的示范，一起推动我们台湾智慧农业的新里程。这个就是我们公司对我们台湾土鸡的一个期望。那我的整个分享大概就是到这里就做一个结束。谢谢各位，
谢谢立瑞畜产有限公司的王雅慧总经理跟我们谈台湾土鸡在智慧化跟溯源管理方面的应用。我们刚刚听完了台湾的经验，我们接下来就将视角呢拉到英国，接下来要请英国的专家来跟我们分享家禽农场的技术整合如何开始，还有潜在的机会。那么这个场次呢，因为疫情的关系，来自英国的专家 Mr. David Speller 他没有办法亲自来到现场，所以呢，预先录制了一段影片。那么在演讲之后，我们的讲者他也会远端跟我们连线来回答大家的问题。那么这位讲师他是来自于英国 OPTI Farm 的执行长，他们的公司呢在全球企业方面提供了相关的服务，另外在英国也经营多个肉鸡场。我们接下来就一起来观看 David Speller 他的演讲。
Today, I want to just touch on some of my own experiences and inform you of what I've been doing, what I've learned, and some of my vision for the future. Of course, vision for the future is not guaranteed. It is just my view and my personal aspiration and thoughts. So first of all, just to explain who am I have 3 parts to my business. So firstly, I am a broiler farming business here in the UK. So I operate 6 farms producing around 15 million broilers per year into 4 different processing companies. All of our contracts are integrated, so we take chicks and feed from our customer. We raise the birds and sell back to them the fattened broiler. All of our birds are in open barns. There are no cages here. So open barns where they have daylight and good ventilation. So that is my foundation. Because of my innovation and the way I think, over the years, I have used my farms to do a lot of research and development of products, both EU funded or British government funded, or in many cases commercially funded by companies from around the world. So we test products, ideas, develop new technologies on our commercial farms in the UK and some of our clients' farms around the world to see whether or not we really are going in the right direction and using products and data and ideas in the best way. So that's quite a big part of my business now. And then the third part is Optifarm, which is a spin out from my farming business, where now Optifarm is connecting to all of our clients' farms all over the world every 90 minutes, 24 hours per day. I have people that physically connect to those farms and check the technology, check the data, check the birds, communicate with the farmers, make sure that everything is optimized and the birds are achieving what that company wishes to achieve. Sometimes slow-growing birds, sometimes fast-growing birds, but we work in all languages, all countries, all over the world, 24 hours per day. So we get to see quite a lot of what is happening. What I would sort of just start by saying is, for all of us, what seems new and futuristic very quickly becomes the normal, and we forget how quickly things change. And here in Europe, we only saw the iPad. We were probably a few months maybe behind yourselves, but we first saw iPads in April 2010. So before this, we had iPhones, but we didn't have iPads, and we had very limited touchscreen technologies. Within 10 years, pretty much everything has gone touchscreen, and my children of very young age can work an iPad and think it's perfectly normal to have an iPad. That was only 10 years ago. And actually, when I look back, I see things like 10 years ago, we never had Netflix, we didn't have WhatsApp, we didn't have Instagram, we didn't have Uber. There are many, many things that come very fast and suddenly become the norm. And so what seems strange in poultry farming today, in 10 years, could just be considered normal. So let's start from, what do I want from digital solutions in my business? Well, the first thing I want to reduce risks. I want to make sure that I know what's happening on my farms at all times and remove any risk. By doing this, I want to understand more about what's happening and why. And a lot of it is about the why. I might already know things are happening, but do I really understand why they are happening? Once I understand this, I can start to work on consistency of my production. I do not want 6 months of good production and 6 months of bad production. I want 12 months of good production because this makes me the most money. So consistency of my production process is really important. And of course, I want to keep my customer happy. It's really important. With no customer, I have no business. So I must do whatever they want. And if they bring new standards to me, I must put those into my business and make sure that I carry out their desires as well as what I want to do as a poultry farmer. And sometimes we see a little bit of conflict around some of this, but it's important to keep the customer happy. And finally, I want to make more money. I do not want to put digital solutions and innovation into my farming business just because it's a good idea. It must make me more money. And today, I would like to say I'm achieving all of these 5 things in my business. But it's a digital journey. We're on a journey. I'm not at the end. I've started. So I start with collecting some data like water intake, temperature, relative humidity, air pressure. Just some basics is where I start from. And this is where I will take a client on a journey when I work with them around the world. Start collecting some of the easier things first, and then through the presentation you'll see we can go on to some very complicated and exciting things, but we start with some simple things first. What you then must do, really importantly, is record your observations and make sure that we link with the observations the data that we see and try and understand what we're seeing happening physically in the barns as well as what we see in the data. But before you overwhelm yourselves, make sure you use what you have and confirm some decision making and improve things on your farms before you get overwhelmed with data, because it's very easy to get overwhelmed with data. Then we move on to the more complex things the data, and driving complex learning. But there is so much we can learn from data, from simple data today, before we have to explore some of the more complex things. Then we move on to the more complicated things. And I mentioned that I want to make more money. This was a slide that I put into Australian dollars. But on one of my sites, I tracked the difference before and after I used innovation and technology. And I was always a better than average farmer. My farm was always doing well. I have good staff, good facilities, and we do a good job. However, by bringing in precision livestock farming, innovation, and data, my advantage on the rest of my group grew even more. Yes, there is variability. We all have good birds, bad birds, good cycles, bad cycles. But on average, there was a very clear step change that occurred when I brought new innovation and data to my business. So it can pay for itself, and that's very important. So if I want to then show you some examples of what we're doing, there's just a nice quote here which says, if you always do what you always did, you will always get what you always got. And if you always got something that you think is perfect and you never want to change, then there is no need to change. But I think we all see the benefits of moving forward to try and get something that could be better, or meet new demands of the market, or have to produce at a lower cost because the market prices are actually in real terms reducing, not going up. So water data I mentioned early on. This is a slide looking at water data over a period of 15 minutes and tracking what the birds are drinking every 15 minutes. And it's not a very complicated set of data. It's quite simple to gather. But first thing I can see here is when the birds have a rest period, because there should be no water drinking when the birds are in the dark and they are resting. So simply from water data, I can tell whether a client is allowing their birds a rest period and what that rest period is. I can also see some peak demand after the birds have had a rest period, which is normal. The bird will wake up and it will want to eat and drink. But I'm looking at how much do they drink and for how long is that peak? Do I have enough drinkers for them all to get water in a suitable time frame, or does it take a long while for everybody to get a drink? So it's important to look at peak demand after a dark period. What's interesting here is there's no peak demand before the dark period, which you might expect if the bird was in more of a routine. I can also see from this graph 2 periods when water goes down, and this is due to the stockman or the farmer entering into the poultry house and the birds stopping drinking to have a look at what's happening. So even from water data, I can tell you how often people go into those chicken houses and go and look at their birds. So there's a lot of information from water, and we use water really for everything from bird health, because we want to, we can see differences in water trends. We can see activity, because if the birds are not active, they won't be drinking. We can potentially predict growth, because they must be drinking water if they're going to be growing. So there's a whole number of things that we can pull out just simply from water data. We then like to use cameras, and we find cameras very, very useful for us. And so this is a slide showing where we looked at some birds where they had poor spread, poor distribution because they were cold with bad air movement. And the bottom picture shows you what happened within an hour when we remotely altered with the farmer some of their settings. We improved the ventilation, we made the birds more comfortable. And from the bottom picture, we can see more birds are eating, more birds are drinking. There is a much better spread distribution of the birds in the house. Therefore, you will get better growth, better feed conversion, and better performance. So very powerful camera images. And I will show you some other slides as we go on of how far we're taking some of these camera images. It's a powerful tool that a farmer would use. Go into a barn, look, smell, listen. We're trying to digitalize effectively exactly that same process. And here's another slide where using today's cameras, and these are just security cameras that you can purchase from any local security firm, just good quality, waterproof cameras. We can pick up where drinker lines are leaking. We can look into feeders and see, is there too much dust? Is there any food available? What height is the feeder and the drinker? Is it the correct height for the birds? How much activity is around those feed pans or drinkers? So really powerful what we do. And you can see the picture on the left is one of our messages to a client, and you can see this is actually a Danish client, but we put messages out in dual language. So we use multiple languages when we're communicating around the world. So what delivers the most value? Well, firstly, I would say technology that does what it says it does, and it must do it 99% of the time. This is really important. Don't come to me with technology that works 80% or 90% of the time. It must work 99% of the time, which is a big request. I also want technology that's actually going to be used in decision making. Give me technology that helps me to change what I do for the benefit of the birds and my business. I don't want technology that just looks good, sounds good, or might make a very nice article in a magazine. It must help me to make a decision within my business. And I want technology with good support, because what we do find is a lot of technology comes from smaller companies that don't have the resources around the world. I put the technology into my farm. When it goes wrong, they're not able to come and support it on a Saturday or a Sunday. So my own team start to try and fix the technology. And at the bottom, thankfully, is not actually one of our situations, but it gives an example. What happens is my farm staff take computers to pieces, and they are not computer engineers. So it's really important that this technology works reliably, delivers and allows me to make decisions. And when it isn't working, I have good support from the technology company to help me to make sure it is working going forward. So let's have a look at some ideas of things that we're seeing. One of the things we see a lot around many parts of particularly Europe at the moment is on-farm hatching. So we have a number of clients doing it in different ways. There are some that put the eggs in boxes or put them in the bedding material on the floor. Others have very sophisticated equipment from companies like Vencomatic that bring the eggs in, allow the eggs to hatch, and then help you take the eggs back out again. But there are many systems there. Some cost lots of money, some cost less money. And you find that the ones that cost less capital cost take more labor to manage. So you either pay in capital cost or you pay in labor. And that depends on your circumstance, which suits you better. You take eggs that have been incubated for 18 days and you place them in the barn and allow them to hatch out in the barn. In reality, we see birds then hatching between day 19, 20, and 21. So birds are coming out anywhere in that period. And that is a period we monitor to try and get most of them out all at the same time. But of course, there is some variability. What I would say is people have to be careful of some of the waste, because now they have eggs that didn't hatch, they have egg shells, they might have packaging. There are new problems with waste on the farm that the farmer didn't have before. I also just wonder whether farm managers are always good enough to be a hatchery manager, which is what you're asking them to be when you are hatching on farm. So it requires a new skill set. You have to monitor eggshell temperatures. You have to monitor the hatching window. You have to manage those eggshells before and after. So it's a new skill demand. There may be more demand for vaccination on the farm because you're not vaccinating these chicks at the hatchery any longer. So you will probably be vaccinating them on the farm at day 8, 9, or 10, which is an extra challenge for that bird when before it would have been done in the hatchery at day 0. So the vaccination program does change, and it depends on your disease pressure, how viable it is. But there is a good question around how much less stress does this put onto the chick? And for consumers, particularly again in Europe, but going around the world, we're seeing more and more consumers thinking about where their chicken comes from. The concept that the bird hatches in the barn where it's going to live is a nice one. And the consumer really likes it. So there is potentially less stress on the chick because it's moved while it's still protected in the egg. And it's quite a good story for the consumer. And we see our clients who do this very well around the world getting very, very good results. But the ones who do it badly get bad results. So I'm going to show you just a short clip of this in action. And this... this is one of the mechanical systems from Vencomatic, but it shows you the process nicely. So I think that gives you a good idea of some of the on-farm hatching. And if we move forward into some of tomorrow's new innovations, robotics has got to play a big part in the future of poultry farming. One, because of the issues around labour around the world, getting good people on farms is very difficult, but also because there are some tasks that robots could possibly do very efficiently once we've developed the technology. So there are different sorts of robotics that we see. And this is a version called Chicken Boy from Pharmatics, which is actually a robot on a rail that moves above the birds. And we will see a version of it in a short video clip. But it can look at the bird droppings and start to understand the health of the chicken based on images of the bird's droppings. It can identify dead birds and tell you where they are in the barn, and quite a lot of information as well as temperature, humidity, and airflow. There are then free-moving robots moving around, which have more impact on the bird's behavior. They can do more physical tasks. They could pick up floor eggs, or they could disinfect the facility. People are developing them to move the litter. And I would say as well, we are developing with a company a product which is for caged birds as well, where one of these roaming robots will go up and down between the cages, looking in at the birds in the cages and sensing what's happening in those cages. So it's not just for open barn, it is also for caged birds around the world. But I also wonder, and I'll show you a clip, whether we could use robotics to do veterinary postmortems remotely. And we want to look at things like new behavior from this real-time analysis as robots and sensors move amongst the birds. And there must be new insights that we can capture. And some of the new things we're learning is around stress responses for the bird and what happens when they run out of food, or what happens if equipment fails, or what happens if you go in there and you catch some of the birds and leave some behind to grow bigger. We find very big impacts on the bird and its brain and its activity through those behaviors, which we never knew until we got data from robots. And we also see things like dominance in a flock, where certain birds will sit near to feeders or drinkers and control all the other birds' access to that feeder or drinker. And by putting robots in, we can disturb this behavior because that dominant bird starts to focus on the robot, which allows other birds to come and eat and drink more often. So some of this is what's creating the much better results from having robots, not just because of the job that the robot is physically doing. So some really interesting things.
We all know broiler farming is not the game.
So this is the Chicken Boy version. It's one of the earlier versions, but in a minute we will see it just moving above the birds. And I'll just show you the clip so that you can see the speed and how it moves above the birds. So here you can see the birds are not scared of it, and it just moves slowly above the birds, up and down on a rail, monitoring as it is going. And we have one of these in our farms in the UK under test at the moment.
Equipment operation in farms, farmers, stock persons or vets via mobile alarms. Farmers access the information collected by the chicken boy
and lots of data, as you would expect.
Anytime, anywhere. Together with the chicken boy, Pharomatics also introduces its digestion index, a measure for dropping quality that is determined.
So this is just talking about some of the artificial intelligence that they're using to analyze the droppings from the bird. So in the interest of time, I will just move forward and show you this is another version that's not so sophisticated in gathering data. But what it is going to do is it's going to move amongst the birds and change their behavior much more than the chicken boy Pharomatics. So it doesn't know where it is not collecting data, but it is moving around amongst the birds and making them move and disrupting the flock a little bit, creating activity and impacting on dominance. And this one here, the idea is that it's minimizing floor eggs by disturbing the hens before they can lay too many eggs on the floor. But there is good data coming back from this robot. Simply by changing behavior within broilers or breeders, you get better performance. Without the data or anything else, that is an extra when that comes later on. So thermal imaging is then the next thing, and it does link a little bit with robotics, because yes, we can use thermal imaging for ventilation and heating. This is us using it in a barn, looking at the cold air in Europe going up in the roof and the warm heater pipes on the side of the wall. But if we're close enough and link thermal imaging with robots, then maybe we can start to watch the digestion process of these birds, and we can see the food being digested internally. We could maybe also use the thermal image and the heat spot for us to count exactly how many chicks are present. We can also be close enough to the bird with robots to start to identify health of the birds and the body temperature. And we can look at how they're distributed around the barn and spread around the barn. So lots more we can do with thermal imaging, especially if we link it with these robots. And a lot of technologies are like that. If we get what are already technologies on their own, like thermal imaging, and combine them with a platform like a robotic platform living with the birds and moving with the birds, there is a huge amount of information. But we must be careful we don't get overwhelmed, but there will be a lot for us to learn. Sound is one that people have looked at for a long while and is really coming on very fast now. We know that there are certain noises chickens make that mean certain things. But the big issue we've found with 10 years of working with sound in poultry facilities is what you do about the background noise. When fans are on and off, when feeders come on and off, when there's a noise outside of vehicles or lorries, it disrupts the analysis. And how do you listen when you might have 45,000 chickens all talking at the same time? Which one do you listen to? Robots roaming might help because, again, linking this technology with robots, you'll be closer to the birds. So maybe we can pick up individual bird sounds. And we're looking at what space technology does and how they listen to the universe by listening in patches through different listening devices and then using software to bring that together in one big sound map of the sky. Could we do the same for poultry, where we listen with many, many microphones in a poultry house and then bring it together through software? But also, I think we shouldn't just listen to the birds. We should also make noises that stimulate the birds. So we need to understand not just what they're telling us, but what we could do back to them to improve things for them. Maybe stimulate feeding, stimulate drinking, stimulate rest periods. There should be sound two ways. Then we have automated image analysis going back with the cameras. And of course, a lot of this comes from humans and what we're doing tracking humans and vehicles. And we've seen a lot of this, especially with COVID around the world. but also we're training simple camera technology to turn around and have a look at a door and tell me is the door open or closed. Have a look at a switch for a fan and tell me is the fan switched on or switched off. Have a look at the height of the drinkers and tell me is the bird reaching at the correct angle to drink, or does the drinker line need lifting or lowering? And we can achieve a lot of this with non-specialist cameras, which is really, really good for the cost implications of what we're trying to achieve. And here, this is a slide I'm just going to run for a little bit where we're working, trying to look at a much bigger image of the chickens down the house, and we're trying to pick out what the chickens are doing using computer technology. So we've trained the computer to identify birds that are drinking, birds that are eating, and birds that are doing other things. And we will go on to develop this into birds that are scratching or dust bathing or playing or being aggressive. But the important thing is we can count them as well as see what they're doing and start to get fresh data on how many birds drink, at what time, and for how long, and track individual birds. What does an individual bird do? But really interesting questions come up, like when is a bird drinking? And when is it just stood next to a drinker, not actually drinking? So there are some fresh complications, but it's something we're very committed to and we're developing very fast. Of course, through all of this data, everyone talks of machine learning, and I needed to be clear in my mind what I'm trying to achieve with machine learning. For me, I have some flocks that are not so good at the beginning, good in the middle, not so good at the end. I have some flocks very good at the beginning, but not so good for the rest. And I have some that are not very good until at the end, and then at the end they seem to grow very well. And what I really want to achieve is by taking all these three, which really give me the same outcome, process the information that's there and come up with, well, how do I get good at the beginning, good in the middle, and good at the end? And that is a very big step change. And that is why I want machine learning for my business and why I want all of this information to be processed. There are some other technologies that I will mention. We've worked a lot with e-noses and picking up a change in the signature of the volatile compounds in the air 2 days before we see any physical symptom in the birds. And the graphs here are from one of my farms where we tested this technology. The top one is a signature of a fairly healthy standard barn. And then the bottom one is that same barn the following day. And suddenly we saw a step change in the data that was coming from these sensors. And this was all occurring 2 days before we saw any physical symptoms in the birds. So it's a tool that allows us to react faster than any human could do with their eyes. And we know they use this type of technology for things like detecting bed bugs in hotels. And so it is a commercial product. And imagine if we could place this technology on a robot, again, bringing robots in, I could detect a disease coming in one end of a poultry farm and watch it spread to the other end of that barn. At the moment, I just wait till the whole barn has a problem. But I could start to see diseases spreading around. This is a clip which just shows, going back to the robotics and remote postmortems, this is a clip of a surgeon operating on a human from some 50 kilometers away using 5G technology. And in time, surely we can use this type of technology to do postmortems on our chickens, with a veterinarian remaining safely away from our farm so he doesn't bring disease and we don't take disease to him or her, but still getting very efficient and skilled people involved in our birds and carrying out postmortems. So if you can remotely operate on a human, I'm sure you can remotely do some postmortems on some chickens. The key there, though, is things like time lag of the internet. If you move your knife, you want the knife to move instantly wherever the operating end is. And that's where you need very fast internet like 5G. So I then move on to things like smart glasses. We've seen these used in engineering industry. We know that in the aviation industry, they use them for training and monitoring what their staff are doing. And we're sort of looking at things like virtual reality and augmented reality. So, for example, here we can see a picture of an engineer where a jet engine is broken down for him and he can understand better how to fix and take apart a jet engine. But imagine you could be walking next to your poultry farm and you look at the building and you see through the walls and you see your birds without necessarily having to go in there, but you could quickly have a look at them. Or you could pick up a bird and based on data that we're gathering around its predicted health status, maybe there's some images of what we might think would be going on internally inside that chicken without killing it and opening it up. There is all sorts of things we could do with virtual and augmented reality, as well as using it, and we're starting to use it now ourselves for training and helping people and saying, let me see what you see, and then I can train you remotely. But we could have virtual signs. You could do the remote postmortems with not having a robot do the postmortem, but the farmer do the postmortem wearing a camera under the instruction of the veterinarian. Lots of different things that we could do. And we could also possibly start to understand and see in a virtual world exactly where the airflows are within our chicken farms. And I was always told if you could see the air move inside your chicken farm, you would never have a ventilation problem. But because we can't always see the air, that is not always possible. So here is a clip where someone has created a virtual airflow image of an office. And we can see the warm flows of air and the cold flows of air and the turbulence. If we could see this sort of thing in a poultry house, it would really help us to understand how to set inlets and fans and design poultry houses maybe better. So it's the next step using augmented and virtual reality. We could use similar technologies for subgroup management. As I've said, in Europe and Australasia and the US, we have a lot of clients with open barns and a lot in Asia as well. And these barns are getting bigger. And maybe we want to manage smaller groups within a big group of birds. But putting fences and physical barriers can be a problem and takes a lot of labor and a lot of cleaning. We could maybe use robots to separate the birds. But what if you created an image of a wall? Will a chicken walk through a virtual image of a wall? I don't know, but it would be something easy to manage because there's nothing physical. It's just a trick of the eye. So we don't know how we would have to present it for a chicken to see it, but chances are they wouldn't try and walk through a solid wall. But could we also stimulate them by giving them artificial trees, artificial hedges, and maybe even go on to say, bring the outside sky in? Could we project images of a nice, bright, sunny day on the roof of our chicken houses inside, such that the chicken feels that it's outside and it can be stimulated by weather effects, which may or may not be beneficial? We'll have to learn this. But here's a picture actually where an airline industry was going to do this. So when we flew, we would see the sky above us. So we know that does exist. So if I just want to start to wrap up and look at, well, where should we start with all of this? Where do we go to start with? Well, first of all, everyone is different. So no one can copy each other. We must think about what we want. We're all different. Ask why you're doing this and decide what you want to achieve before you go and spend lots of money and lots of time. Think if you would gain more by using some outside help as well. We often use experts in our business from outside, but we don't when it comes to innovation and technology. And maybe we should. Clearly set a budget, because we all have limited resources and we mustn't just go and spend hundreds of millions of dollars unnecessarily. And be sure to evaluate the outcomes to know, was it successful or not? And even if it wasn't, okay, I've learned that it wasn't successful, but at least I've evaluated the outcomes. We see a lot of big data, and the term suggests that all will be well with big data sets in the world. From this big data, machines will learn everything and we will know everything. Well, from my experience, this may not be true, certainly initially. What I've discovered is that big data and machine learning, from us working with it for a number of years, requires a lot of teaching. You must first teach the computer and the machines what they must look at and what they must analyze, and then eventually they will start to bring you new learning. But they do not bring you new learning on day one. And the agricultural industry is very nervous about sharing data and putting data in one big data set where we can all learn. And I understand this, but it's something that we may have to get over. And there are also concerns over one person's data helping their competitor. If I am a company A and I compete with company B, I don't really want my data going into a big set of data, which you will then give fresh advice to company B and make them better. Unless we see benefits of combining it so that what I get from company B helps me and what he gets from me helps him, and we both keep going up together and keeping the competitive differences, then there will be a problem. And no one wants this to happen. And what they say is we would rather all stay where we are today than potentially see one or two of our competitors get better while we don't. So it's a big challenge at the moment. When we look at digital capabilities and the problems, not everyone has the same ability around the world to gather and use data. And we need to think maybe start where you have a good internet connection, where you have reliable equipment, and you have lots of data gathering opportunities. So start with a few farms where you have the best resources. Farms typically are remote, they have poor internet, they're spread over big areas, and they're full of old equipment with no data gathering. So we need to think about how we're going to work with some of these sites. And the farms themselves are not always able to exploit the value of the data. Depending on their contracts with their customers, we may find that actually someone else within the production chain is going to make the money from the data and the new learning, maybe the processor or the retailer or the hatchery or the feed mill, maybe not always the farm. So we need to think about who's going to pay to get this data and who gets the benefit from the data. But I will just sort of end by saying for all of this, we must just remember that food is changing around the world. We are seeing more and more synthetic food, laboratory grown food. Artificial eggs are a real thing now. We see raw ingredients going through printing machines and printing food. I know of restaurants here in the UK and London where the whole restaurant, when it was open pre-COVID, was 3D printed. The furniture was 3D printed, all the food was 3D printed. Everything in that restaurant was 3D printed. So we know that technology is there. And meals made from alternative raw materials. So again, meat alternatives, substitute products are coming into the market. But we're also seeing a movement in many parts of the world to slightly reduce per person the amount of meat intake. Not always the case maybe in Asia, Southeast Asia regions, but I'm looking globally and saying we do see some movement. But we do also see population growth, so the overall demand is still upwards. But we must be mindful of some people and the vegan movement. And perceptions. Let's not forget that not everybody understands our industry, and what people think of as a natural chicken to us is probably an unhealthy chicken, and what we think of as a healthy broiler, they probably think of as genetically modified or artificial. So perceptions change, and we must be mindful of perceptions. So the final slide to close then, just a closing summary. Technology can help us understand more and learn new things about our birds and our farming businesses anywhere in the world. Really important. We should and will always have some human-bird connection for as long as we are farming poultry, whether it's indoor, outdoor, in cages, in barns. There will never be a time that I see at the moment where we remove all humans from growing birds. If you get to that stage, you are probably going into laboratory grown meat, not farmed animals with no humans. Technology, I would say, can never replace a good farm manager or a good stockman. But when you combine technology with a good person, you get a very powerful tool. So that's what we're about, is linking these two things together. And finally, none of us should feel threatened by the opportunities that technology offers. It's there for us to use it to our advantage. And for those of us who want to embrace it and can embrace it, it gives a real opportunity of some advantage. But it comes at a cost, and it's unique for what each individual one of us wants to achieve from it. So there is no something that fits everybody. And really there, I would like to end it and take any questions.
那么我们接下来就邀请我们刚刚第一场的讲者王雅慧总经理，以及这个场次的主持人行政院农委会畜牧处家禽科的李怡谦科长到台上来就座。那么同时，我们英国的专家 David 也已经在线上了。Hello, David. Very good to have you.
Good afternoon.
Thank you for your wonderful presentation and thank you for your time to join us today for the Q&A session. Most of the questions will be in Mandarin, but we will interpret that into English for you.
That's perfect.
And with that, I will turn it over to our moderator. 我们接下来就将时间交给科长。
谢谢在场的各位老师、各位同学或者是各位业者。今天我很高兴能够代表农委会来主持这个阶段的我们的讨论的议题啊。这个议题是针对我们家禽在智慧农业方面的运用。那其实诚如刚刚两位专家所报告，要达到智慧农业，必须依靠很多的设备跟收集的资讯。那收集的资讯，刚刚特别是英国的专家也提到，如果我们收集的大数据、大量的资料没有经过有系统的分析，数据还是数据，资料还是资料，还是不能让我们所应用。所以设备加上系统的分析，那才会成为我们在生产过程当中，能够得到的一些知识也好，得到一些经验也好。因为我们知道，过去的老一辈的饲养者，他们非常有经验，知道怎么养，但是让他说出一套有系统的理论，其实很困难，很困难。所以我们说，经验是没有办法传承的，没有办法。这是累积很多年的经验，他知道怎么样，可是他说不出来为什么要这样子，因为这是他靠他的经验。所以我们这几年利用我们的这些设备收集的这些前人在饲养过程的这些我们收集到的资讯，把它数位化、数据化，把它整理成一套的饲养的 SOP， 所谓的照书养。我们年轻人进来这个领域，他很快就可以上手，就可以透过我们收集的资讯，真的可以照书养。我们建立一套 SOP， 所以这几年我们一直在希望能够跟我们的产业能够来互相的利用我们的家禽这方面的一些领域，透过资讯的系统性的收集、分析，然后把它整理成我们一套的管理系统，让我们的业者能够遵循。这是我们这几年来的一个智慧农业的一个历程，让各位分享。非常感谢英国的专家还有国内的专家都给我们非常宝贵的经验那也是刚刚特别是国外专家提到的未来科技的运用，也是我们目前要走的一个方向。农委会从明年开始有一个5G的，刚刚应该都有提到有一个5G的一个计划。这个5G的计划就可以实现刚刚我们国外专家提到的，将来我们的兽医师可能只要有电脑、有手机，就可以远端的看诊，或许在他电脑上面就有一个3D 的鸡的现场的一个画面，可以透过这个3D 影像来看这只鸡的问题有没有问题。或者是刚刚提到的，我们就模拟在禽场里面模拟鸡是在室外的天空，其实它是在室内，透过这样的模拟，让鸡以为自己是在户外的环境，或许在我们的饲养方面会有很多的帮助。这个是我们将来透过 5G， 当然这个要有5G 高和宽的宽频，然后瞬间可以传递很大资讯的这样一个系统，才能够达到我们的目标。但是我们相信，我们运用了5G 之后，过去电影情节看得到的那些画面应该很快会实现，会很快会实现。好，那很感谢英国专家Mr. David Spader 他们给我们这么宝贵的经验，还有利瑞王总经理给我们这么宝贵的经验。好，我们就开放给各位提供你的经验，或者是给我们提出你的看法。不晓得各位有没有要跟我们指教，或者是针对刚刚2位专家所提到的有什么疑问，也可以提出来。
你好，我来自畜产实验所。我想要提问的是，刚才英国的专家他的研究方向都是在室内的密闭式的禽舍，但是欧盟它的未来的方向，畜产的方向是一个户外开放的饲养空间，不能在室内。那未来这些智慧的科技是否已经有开始在收集户外的 data？ 或是说有没有一些新的想法去应用在户外的情绪的资料收集上面？谢谢。
那请问您是要请教国外专家，还是请教我们国内？
国外专家。
So David, this question is for you. I know that a lot of the research that you have presented apply to indoor chicken houses or enclosed spaces. However, we know that the future strategy of the EU in poultry farming is to go outdoors, to be in open space. So I'm wondering, in terms of the application of smart technologies, are you currently collecting data from outdoors, or are there any other ways or methods that is already being applied or adopted? Thank you.
Thank you for the reality is a lot of data collected outside.
David, sorry for interrupting. Can you try to speak into the camera because you were breaking up a little bit, into the microphone. Thanks.
Okay. Is this any better?
Much better.
Okay. The reality is we do not collect so much outside, and what a lot of European farmers are trying to do is bring the outside inside. So we are having lots of windows in our buildings and using correct lighting to bring the outside in, because it's easier to control than trying to have birds outside. Lots of laying hens for eggs are outside, but not very many meat birds.
其实我们现在就是在收集数据方面，大部分都还是以室内为主啦，收集户外的资讯还有数据相对来说比较少。所以现在呢，其实欧洲或者欧盟很多的农场，他们的做法是有点像是把户外的环境引到室内来，比如说在农舍方面可以有更多的开窗，或者是在照明方面可以做得更好。那其实原因就是说，在室内的环境，它毕竟还是比较容易控制的嘛。那如果说在这个下蛋的母鸡方面，的确是有一些是在户外的，可是其余的话，很多还是以室内为主。谢谢。
不晓得这样，国外专家有没有回答您的问题？
有可以，谢谢。
谢谢。不晓得还有哪位可以给我们提供？来，请。
Hello， 不好意思，我想请教一下 David， 就是像在台湾的白肉鸡我们要达到上市体重大概是2公斤，可能要33天至35天。那我想了解一下，像他们在那边要达到上市体重2公斤，大概花多久的时间？那这是第一个问题。那第二个问题我想问，就是在
所以我先讲第一个好吗？
OK，
谢谢。So David, another question for you. For broilers in Taiwan, for them to be able to make it into the market, they need to be at least 2 kilograms, and usually that takes about 33 to 35 days here. So I'm wondering what is the case for you? What is the weight and how many days do you need in general? Thank you.
So we would be growing very similar genetics to yourselves, so the productivity would be very similar, but the biggest variable is which feed that we give them. Our own farms go into a number of different customers with different feed, so some of those would range from 2 kilos at 32 days to 2 kilos at 34 days, so very, very similar.
我们的情况其实跟台湾还蛮类似的，因为还有就是在产能方面也非常的类似哦。唯一的一个变因应该就是饲料的不同。那像我们的农场，我们也会去提供很多不同的客户做咨询嘛。那不同的客户他会因为饲料的不同而有不同的重量跟天数。不过呢，大概都是落在2公斤32天到2公斤34天左右，所以其实这个情况跟台湾非常的相似。
谢谢。那我的第二个问题是，那在他农场。
所以这个机器人是同一的。
刚刚讲到的是禽舍里面的气流嘛，禽舍里面气流的流动方向是不是？气流方向，它有没有积热，或者是说流传的很稳定，还是说哪边会比较在我们的禽舍里面的气流，其实一般我们在新建禽舍之前，我们都会先经过设计，包括它的长宽，还有它的 系到我们的鸡舍建制的时候，它的硬体建筑。因为一般大部分我们现在的鸡舍的硬体建筑，大部分都是那种科层板，就是一般的烤漆板。但是因为烤漆板其实它是有缝隙的，它的密合度其实没有很好。那在我们气流流动的时候，它就会造成一些死角的发生。那这些死角可能会造成我们整个的气流影响就不会那么的顺畅。那基本上的话，经过设计的情况下的鸡舍气流的流场，它是不太至于说造成我们机场的机制太大的问题。谢谢。
David, would you like to take that question as well?
Yeah, thank you. I totally agree that design is everything, and when you design a good house with the right ventilation system, that it helps. But the main things we then do are lots of testing with smoke, see where the air is going, and a lot of watching the chicken, because they will tell you there is cold air or how they feel. So they are the real big indicator of the chickens. But the key is get the design right, and then go and smoke test and make sure it's doing what you want it to do. I guess the biggest challenge we see around the world is when you want to design a system for very cold winters, but in places where they also have very hot summers. And what you want to ventilate in a very warm country is very different from what you want to ventilate in a very cold period. That is the biggest challenge.
非常同意我们刚刚讲师讲的，就是说设计这件事情非常的重要，然后要有适当的通风，就非常需要重视。那所以说，在设计的时候，当然要做很多的测试嘛，可能用烟雾的方式来测试空气的流动，它的气流是怎么样子。再来就是机制本身，它们也是一个非常好的指标，它可以告诉你说到底这个气流它的状况是什么。所以简单的小结的话，第一个就是设计很重要，再来就是用烟雾来做测试。那现在常常在通风系统方面会碰到的问题，就是说某一个系统设计出来，它必须要因应很冷的寒冬，可是同时呢，它也可能必须要去因应很炎热的夏天。那我们知道说每一个国家它的气候的环境不一样，那这个可能是我们比较常碰到的一个挑战。
表示说台湾的极端气候这样越来越明显。那在这个样的气候环境下，其实对我们鸡舍的设计是非常重要，所以就需要很多的这些专家呢，甚至说。
在中央大学，跟英国的专家问一下他的公司。第一个，他公司的话，我想是专职；第二个，他 IT 部门是自己开发这些软体的话，那想到公司的资金部门的话，那第三个是他的管理阶层的话，因为他要做全球的服务，就想象是自己。
Hi David, I'm a professor from Chongqing University. I have a question about your company. First question is how many full-time employees do you have at your company? And in terms of your IT department, do you develop your own software? If that's the case, how many people do you have under the IT department? Also, how about your management team? How many people are in that team? Because you offer global services, so I'm curious about the structure of your company.
Thank you for the question. So we have at the moment somewhere between 40 and 45 people, so we're not a massive company. We use a lot of partnerships, so we do partnerships with people like Big Dutchman, Stowe, Big big global brands to utilise their resources, as well as local people in many countries around the world. So we are facilitating a team approach. own internal management and service delivery. So we would have no more than 2 or 3 people developing, and then again we use subcontractors to work with us on specific projects. And the management team, we have a classic European management structure. So we would have maybe 4 or 5 very senior managers, no more.
如果以我们公司全职员工来说的话，我们公司不算大，大概就是40人到45位全职的员工。然后我们常常是跟全球不同的公司合作，比如说在热点公司在 Sales， 去运用他们的资源。那再来就是我们在不同的地区的当地也是有合作的伙伴。就软体来说，其实我们服务的客户啊，我们其实都是沿用，大多是沿用客户原本的软硬体，自己的 IT 部门的话。我大概就是2到3人这样，那多的专案可能就会用外包的方式在进行。管理团队、管理阶层的话，其实很类似一般欧洲的企业的这个规模，大概就是4到5个比较资深的经理人。
以我们统计来讲的话，我们是每一批次都会做一个全场的清洁。那当我们在冲击完毕之后，我们会先把第一个动作就是先把所有的垫料都做一个清除。清除了所有的垫料之后，我们会开始做一个清洗鸡舍的一个动作。那当我们的鸡舍清洗完毕之后，其实我们会接下去做消毒的动作。那消毒的动作同时，我们还会再把我们的所有的一些感测设备全部重新再整理过一次。那整理过一次的目的就是，其实我们希望说，我们需要在这个清理的过程，我们也要去检查一下我们的所有感测设备是不是还准确，有没有因为我们的清洗动作或者一批鸡我们可能已经经过了90天之后，它有没有说已经不准了？对，这个就是我们会在清洗之后所做的。那我们做的就当然是就是用先擦拭的，确保说我们擦拭的过程中也是要，在擦拭的过程中就要去检查，是不是设备是没有异常。这个是我们一批次在做的一个清洁。谢谢。那这样子的话，可以这个回答你们需要。
So the other question is about how do you maintain or how do you clean and sanitize the sensors after access to the leaf? Is it very labor consuming? What is generally the process?
This is a really good question and a big challenge for the technology companies. As the technology is becoming more complicated and more sophisticated, we still want to be able to clean and disinfect this equipment where possible in the barn where the equipment is operational. But of course some sensors have to be removed and we have to clean them by hand and then put them back before the new chicks arrive. But for us, we express to the technology companies that we really want technology that stays fixed in the barns and be cleaned in the barns as a commercial process, like the feeders and movers and everything else. But it is a big problem for them as we get more sophisticated.
其实对我们用了很多的这种技术的厂商来说啊，现在在鸡舍里面这方面的挑战是越来越大，因为我们所使用的科技设备是越来越复杂嘛。但是我们尽可能的原则就是说，这些设备最好都还是可以在现场
它是可以直接清洗跟消毒的。那有一些感测器我们就是必须要拆下来用手工来做清洁，这个是在进新的机之前。那如果说我们的这个科技设备厂商的话，我们会跟他们讲说，我们尽可能希望所有设备它是固定在鸡舍里面，而且是可以在当场做清理的。可是这件事情它的确是越来越不容易，因为现在的机械或者设备它是越来越精密，越来越复杂。但是我们还是希望说，感测器它也是可以像很多喂食器或者是饮水的这个器具一样，它是可以固定在现场。Does on-farm hatching reduce the hatch rates, and also does it consume more energy if you do it on-farm?
So the hatch rate is very essential because you cannot add more chicks, so you need to know what your rate of hatch will be. So at 18 days, every single egg is inspected for a live embryo. So the hatch rate is very, very high once they arrive on farm at day 18. And we are not seeing excessive energy use because at day 18 the embryo is generating its own heat inside the egg. So the biggest problem is actually the eggs getting too hot and needing to keep the shed temperature slightly down, not having to put lots of heat into the shed more than you would normally in getting warm ready for new chicks.
对我们来说，的确那个孵化率是非常重要的。所以我们其实是在18天的时候就去看，就是那个这个蛋它是不是已经有卵，然后再来就是，所以说在孵化率方面它应该是蛮高的。然后其实，在年泡方面并没有增加，因为18天的时候，其实它的温度都已经蛮热蛮高了，所以其实没有让它不够热的问题。
Okay, I'm Jeff, working in the Toronto. Can I ask you a question? Is 5G technology deployed in your business and how?
想要问这个问题就是，中华电信的伙伴问说，5G 的技术它现在有没有在使用？如果有的话，是怎么使用？ So David, the question was raised in English, but I guess you cannot hear, so I will repeat the question. So this is a question from a participant from Zhonghua Telecom, a telecommunications company. The question is 5G deployed in your business? If so, how is it deployed?
Unfortunately, 5G in the UK is only available in some city centres. It's not in the countryside where our farms are. So today, no. We have some good fibre optic cables linking some of our premises, but we are behind Taiwan in things like 5G.
在英国的话，其实只有在某一些城市的市中心才有5G 的部署。所以现在像我住的地方，它是比较乡下的地方，所以是没有5G 的。那我的确我们有光纤嘛，但是就在5G 的部署方面，英国是落后台湾的。
其实我刚提到，一定是从现在的开始，从5G这方面再加强研究。在台湾来讲，5G 也是，特别是我们的器材都比较偏离，甚至呢我们用无线网络等，这个都是我们必须要克服。所以 加智慧农业国际研讨会提供的成果展，也特别感谢国内的业者，因为市场公司王总经理，更特别感谢国外的专家 David 这样一个非常特殊的一个公司，全球唯一可以24小时提供服务的公司，也谢谢他提供给我们这么多的宝贵经验。今天非常谢谢他，谢谢大家，谢谢。
再一次感谢科长，还有王总经理，还有 David 的分享哦，也非常谢谢大家今年参加2020智慧农业国际研讨会跟联合成果展。在这边，仅代表主办单位还有协办单位非常感谢大家的参与。但是呢，大家在离场之前有一件非常重要的事情，请大家帮我们填写今天研讨会的问卷。那么在离场的时候呢，将问卷交回报到台，可以换取我们今天特别准备的餐盒。另外呢，要搭乘接驳车的来宾，我们也会在1楼提供接驳车。再一次非常感谢大家的参与哦，然后我们希望下次还可以见到你，拜托提供给我们你宝贵的意见，谢谢。